I am Christine Toribio from BSED Math 2A. Today, I will be discussing about finding the day of the week. Finding the day of the week. In Gregorian calendar, the Gregorian calendar is the most widely used calendar system today, particularly in Western countries. It was introduced by Pope Gregory XIII in 1582 as a modification of the Julian calendar to align more accurately with the seasons. In finding the formula of the week, we have here day of the week is equal to YC plus MC plus CC plus DN minus LYC modulo 7, wherein the YC is a year code, MC month code, CC is a century code, DN date number, and LYC is a leap year code. Year code, YC is equal to the quantity of YY plus YY divided by 4, wherein YY is the year's last two digits. The next step is solving the quantity YY plus YY divided by 4. For example, we have here the year is 1987. So we have here the formula YC is equal to the quantity of YY plus YY divided by 4. So we have here the last two digits, the quantity of 87 plus 87 divided by 4. Copy the last digit, 87, and 87 divided by 4 is equal to 21. Then add 87. The quantity of 87 plus 21 is equal to 108. The next is the month code. The corresponding month codes for each month are as follows. In month, we have here January, the code is 0, and February, the code is 3, March, the code is 3, the April is code 6, May, code 1, June 4, code 4, July, code 6, August, code 2, September, code 5, October, code 0, November, code 3, December, code 5. For example, Angela's birthday is in April. Its respective month code is 6, wherein April has a code 6. Century code. The following describes corresponding century codes. In century have 70s, 80s, 90s, 20s, 2100, 2200, 2300, and 2400, wherein the code is 4206. For example, the year is 1890. The year 1980 includes in 80s. So, each century code is considered as 2. The leap year code. If a Gregorian year can be divided by 4, it is a leap year unless it is divisible by 100. But it is also a leap year if it is divisible by 400. The following examples are more apparent to determine leap year. So we have it 2004 is a leap year because it can be divided by 4. Next is 1800. Is it not a leap year because it is divisible by 100? In 1600 is a leap year because it can be divided by 400. And leap year code. If the date is in a January or February of a leap year, the total sum will have to be subtracted 1 before the final step. So we have here the formula. Day of the week is equal to YC plus MC plus CC plus DN minus 1 modulo 7. Example, January 1, 2000. From the date 2000 is a leap year because it can be divided by 4. It is also divisible by 400. From the theorem, its leap year code is 1 because the date is in January. Day code Sunday 0, Monday 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5, Saturday 6. Example, Nicole was born on July 27, 2004. Determine the day of the week using Gregorian calendar. We have here a solution, July 27, 2004. We have here the formula. Day of the week is equal to YC plus MC plus CC plus DN minus LYC modulo 7. We have the identified codes. Year code is equal to YY plus YY divided by 4 is equal to 04 plus 040 divided by 04 is equal to 5. Wherein the month code is 6, century code is 6, day number is equal to 27, leap year code is equal to 0. Day code. So, we will find the day code. Day code is equal to YC plus MC plus CC plus DN minus LYC modulo 7, wherein equal 5 plus 6 plus 6 plus 27 equals 0 modulo 7. We will add 5 plus 6 plus 6 plus 27 is equal to 44 modulo 7. Is equal to 2. The day code is 2, which is Tuesday.